Lesson 2.5, solving equations involving absolute value. So our objective today is exactly that, to solve equations with absolute value. This is something completely new for you, you have never seen before. The standards is Algebra 1.2.1 because we are solving equations. Basically what's going to happen is you need to think about what absolute value means, and absolute value is the distance from 0 on a number line. So absolute value is the value of the number without paying attention to the sign at all. So the absolute value of 3 is 3, and the absolute value of -3 is also 3, because they're both 3 units from 0. So you really don't pay attention to the sign. It's really the value of the number. And it's called absolute value. It's the absolute value of the number. You don't pay attention to the sign. You have done this part before, and it's just kind of getting you thinking about absolute value again. If you had to evaluate the absolute value of a minus 7 plus 15 if a were 5. So when you evaluate anything with variables, you always plug the value of the variable in, and then you do the steps following PEMDAS. So first of all, we would put in the absolute value of 5 minus 7 plus 15. And you would have to perform what's in the absolute value first. So 5 minus 7 would be -2. But the absolute value of -2 would be just the value 2, and we would add 15 to it, and that would be 17. So the absolute value of a minus 7 plus 15, if a equals 5, would be 17. Alright, so remember absolute value, you're thinking that whether it's positive 2 in there or negative 2 in there, it doesn't matter, that both of them result in 2 that we added to the 15. But we're now going to step up and do equations. To solve, you must consider both of those possibilities, that inside the absolute value sign, it could be either the positive value or the negative value. So what you have to do with these is you're actually going to end up solving two equations, one where it's equal to positive value and one where it's equaling a negative value. So here's what we mean. For example, example B, it says the absolute value of 2x minus 1 equals 7. You have to rewrite with the positive and negative value. So this is what you would write on your paper. You take the 2x minus 1 and you set it equal to 7, or, and you literally write the word or, 2x minus 1 equals -7. We really don't know which one it is, and it doesn't matter which one it is because they both would give you the value of 7. Now you solve them both just like you would normally. So I'm going to add 1, and I kind of do this all at one time. You don't have to. You can do them completely individually. I kind of just do it all at once because you're doing the same things all the way across. So on the left here I would have 2x, that cancels, it equals 8, or 2x, that cancels, and it would be -6. Divide all the way across there by 2, and this one, x would equal 4, and this one, x would equal -3. So I'm going to say that my set of values could be 4 and -3. Those are the two possibilities, and I'm going to put it in set notation, so showing you that there's a set of answers that could make that true. 4 or -3, and that's why I put it in set notation. Questions about that? Yes? What? Okay, because if you had absolute value of 7, what would you say that is? 7. And if you had absolute value of negative 7, what would you say that is? So couldn't the inside be either one of those and still give you 7? That's why you set the inside equal to both of them, because we don't know which one it is. So the inside, the 2x minus 1, could be the same thing as 7, or it could be the same thing as negative 7. It could be either one. We don't know. You have to consider both of them. So in absolute value equations, you're going to have two answers. Okay, you're going to have both. All right, anybody else? So if we have absolute value of 3z minus 3 equaling 9, somebody want to try this one? Josh, what are you thinking? Okay, first you got to rewrite your equations. Okay, so you have to write that they could be, that in the middle could be 9, or it could be negative 9. We don't know which one it is. It could be either one. Question?
But the negative 3 and the absolute value, would it still be negative?
Yes. The part that's in the absolute value has to be exactly the same in both. It doesn't change. But when you solve that whole part, 3z minus 3, we don't know if it's a positive 9 that it equals or a negative 9 that it equals. But either way, it's exactly the way it's written there. It is 3z minus 3. That's what it is. It doesn't change. That part stays exactly the same. Josh, what am I going to do to solve this? I'm going to add 3 all the way across. Oops, didn't mean to cross that out. Okay. 3z equals 12 over here, and 3z equals negative 6 over here. Okay, and then divide by 3 all the way across. So over here, z could be equal to what? 4. And over here, z could be equal to, what is it?
2.
No?
Oh,
Negative 2. So my two solutions would be 4 and negative 2. Now what that means is if I would take those two numbers and come up here, if I would come back up here, I would get 9. Because 3 times 4 is 12 minus 3 is 9, and the absolute value of 9 is 9. Or if I use negative 2, 3 times negative 2 is negative 6. Negative 6 minus 3 is negative 9. What's the absolute value of negative 9? 9. So either way, it would work. Those two numbers are the answers. When you have absolute value, you're going to have two answers because you got to consider the positive end and the negative end. Questions? You got to rewrite it and solve both. It doesn't change what's inside the absolute value, only what it's equal to. Okay, let's look at example D. Absolute value of p plus 6 equals negative 5. Okay, now here's the problem with this. Absolute value equals negative 5. What that is saying is that the distance this is from 0 is negative 5. Is anybody thinking anything weird about that, my tree? You can't have a negative distance. So, absolute value cannot equal a negative to begin with. So this answer would be empty set. Do not be tricked by that. You cannot say the absolute value of anything is a negative answer. It can never have a negative distance. Okay, the part inside of it could be negative, but the absolute value of it cannot be negative. All right, questions about that? So they're going to be a little more complicated. They're going to add some things, and they're going to make absolute value part of an equation. So you might get something like this. 6 plus 4 times the absolute value of x equals 10. And you've got to get that absolute value by itself before you can rewrite the two equations. Ben, you got a question? Do you know how to do this one? Okay, what are you going to do?
I'm going to put 6 plus 4x equals 10.
Nope. You gotta solve for the absolute value of x first and get that alone, and then rewrite the two equations. My tree?
I have a question.
You have a question. Okay.
Could this one equal negative?
This one could equal negative 10. It's just that when you get down to the absolute value by itself, it can't be negative. Okay? Question? Okay, you have a question? Okay, well, Jared, see if you, okay, go ahead and tell me what you think you should do. You cannot do that. That's why don't we let me do this one, okay? Because I'm not sure we understand what you have to do here. So, again, it's 6 plus 4 times the absolute value of x. And what you've got to do is isolate the absolute value part by itself. You would treat it like it's just a plain old variable. But honestly, there might be something else inside that. Inside the absolute value, it could be x plus 3 or 2x minus 8 or anything. But right now, that one just has an absolute value of x by itself. I still have to isolate it by doing this. You would subtract 6 from both sides. Just like it was solving a regular equation without the absolute value sign. And that would make this fall out. You would have 4 times the absolute value of x, and that equals 4. And since it's 4 times the absolute value, you're going to end up dividing, making that fall out. And what happens is, and I'll come up here, is it says the absolute value of x equals 1. Now, when you get the absolute value by itself, that's where you write the two equations. So you would say x equals 1 or x equals negative 1. And there's no solving from here. It just so turns out that that one's already down to just a regular x. So your two solutions would be 1 and negative 1. I do want to say that if you would get one where you would solve it and it would come down to, let's say that said x plus 3 equals 1. Well, then you'd have to go one step further when you rewrote it. You'd say x plus 3 equals 1 or x plus 3 equals negative 1, and then go from there. Okay, so that could be a possibility. Now, my tree asked this question. What if it was negative in this situation? Okay. So let's say it was something like this, and I'm thinking of some options just in case you run across this. Let's say that it would be negative 8 plus 4x, no, plus negative 8 plus 4 times the absolute value of x plus 2 equals negative 6. Can you see that? And in this case, when you go to add the 8, you would have 4 times the absolute value of x plus 2 equaling 2. I know this is really bad writing this like this in the corner. But it ends up being a positive when you get the absolute value by itself. And when that happens, it's okay. Okay, when that happens, that's okay.